Okay, children, now I thought that I have to discuss that pH calculations and acid-base equilibrium contents with these tubes. So in my case, I personally experienced that most of you are not doing that uh, according to the time allocation that I have given. I mean, every week you have to submit it to me. But it's not happening regularly, so I decided to make some YouTube videos and publish that in YouTube, so then you can see that at any time, and you can work out with that thing at any time that you want. Sometimes that will be helpful, I guess. So this is what I am going to give you today. I mean this week. That is regarding the strong acids, weak acids, and the pH calculations. Let me show the tute for a while. Um, in 1 minute, I will show you the tute. So this is the first question. The first question says something like this. Dihydrogen phosphate and hydrogen phosphate ion is an important buffer in the human body. In this system, there are two acid-base conjugate pairs. These are, the question is like that. You have the question with you. So I will not share it more longer now. Right. So you can see the question in your tute. So now this is something like this. Now when they ask this question, regarding the acid and base, let me to write what they have given there. Let me write it. So it will be like this way. H2PO4 minus, this is H2PO4 minus, this ion is reacting with water and it produces an equilibrium like this way. It produces an equilibrium like this way. It makes H3P, sorry, HPO4 minus, it makes HPO4 2 minus and then plus 1. H3O plus. H3O plus. So this is how it happens. So there are in this system, there are two acid-base conjugate pairs. These are, now we'll see which is conjugate acid and which is conjugate base in this pair, right? So it will be like this way. Now you see H2PO4, you see two hydrogen here, and you see only one hydrogen here. That means this hydrogen is donated H plus to this water. So this is the donor of H plus, so he donate H plus. H2PO4 plus donate H plus, so this is the acid, right? Let me to say that is acid 1. And then this is the one which accept that H plus. H plus acceptors, proton acceptors are base. So I will say that is base, right? So I will say that is base 2, right? Now the next one, concern the reverse reaction. Concern the reverse reaction. In the reverse reaction, here 1 H, this side 2 H. And there are 3 hydrogen and there's only 2 hydrogen. That means H3O plus. That means H3O plus is the one which donate H plus to this thing. So this H3O plus is the donor of H plus. So he is the acid. This is the acceptor of H plus. So that is the base, right? So this is the base. Now see this one. Now see this one, this is the acid one. Acid one day makes the its own base. So this is the base. And this is the base 2. It is derived from the acid 1, acid 2 like this way. So water and H2, H3O plus act as a one conjugate pair. And and this acid 1 and base 1 act as another conjugate pair. So according to that, the answer is the first one. Right. Okay. Now I go to my next one. That is second question in my tute. Uh, the formula that can be used for the calculation of the pH of this buffer solution is, now this equation that you see in the question paper is called Henderson equation. That's called Henderson equation. We use this Henderson equation to find the pH of the buffer, right? pH is equal pKa plus log value of, here this is the salt, I mean HPO4 2 minus, divide by, and the denominator is H2PO4 minus, right? Now all the informations are given here. pKa value is given here. H3, this pKa value is given in the tute, right? In the information, set of information supplied, pKa value is given, and HPO42 minus concentration is, this one is given, and this one also given. That's very easy. So we have to find the pH directly. pH is equal, pKa value is printed in the paper, 7.2 log bracket, the numerator is HPO42 minus, its concentration is 3.98 into 10 to the power minus 8. Yes, then the next one is H2PO4 minus, its concentration is 3.89 into 10 to the power minus 7. So if you use your calculator, your final answer will be 6.21. So that is the answer. Now, children, I go to my third question. Right, so we see the third one. Um, Third one is regarding, calculate the pH of the solution of HCl concentration 0.25 moles per cubic decimeter. Calculate the pH of the solution of HCl concentration 0.25. So they asked me to find the pH of HCl solution. There is a HCl solution. There is a HCl solution. Concentration of HCl is how much? 0.25 moles per cubic decimeter. They ask what is the pH of that. They ask what is the pH of that. So we are to find the pH. So HCl is a strong acid, so it is strongly ionized to give H plus ions and Cl minus ions. Okay, HCl concentration is given by them, that is 0.25. That HCl is a stronger acid, so it is fully ionized. That means H plus concentration also 0.25 and Cl minus concentration also 0.25. Now, Puta, we know H plus concentration. We know H plus concentration. So we can directly find the pH very easy. pH is equal minus log, what is that? H plus concentration. So pH is equal minus log 0.25. So then pH is equal minus log 0.25. The answer is right. So then this one is, the answer is 0.6. If you use a calculator, you can find that the answer is 0.6. Right. So that is how we get the answer for that question. Now we go to the next page of the tute. And that the question to be discussed is the third one. Right. Now I got next one. The select the correct pH for the following solutions. First one, they ask what is the pH? Again, they ask what is the pH of the solution. They ask what is the pH of the solution if the concentration of the nitric is 2 moles per cubic decimeter. So they have given the acid. The acid is nitric, and then the nitric acid is strongly ionized. You know, it is monobasic acid, so it is 1H plus, and the next one is NO3 minus nitrate ion. So according to the question, this is that concentration of nitric acid is 2 moles per cubic decimeter. So H plus concentration also 2, right? So that's very easy. We know the H plus concentration. So we assign that pH is equal minus log H plus concentration equation. pH is equal minus log H plus is 2. So pH will be negative value this time. It is pH minus 0.3 is the value. Okay, that is how we get the answer for the question 3A part. Now we go to the next one, question 3B part, right? Now I go to the next one, that is question 3B part. That is, they are talking about 0.1 moles per cubic decimeter barium hydroxide solution. Now our subject is about the barium hydroxide solution. The barium hydroxide solution concentration is given. See, the concentration of barium hydroxide is 0.1 moles per cubic decimeter. I represent that by letter M, right? The barium hydroxide is a dibasic, diacidic base. So it gives Ba2 plus and 2OH minus, right? It gives 2OH minus, you can understand that, right? It gives 2OH minus. So barium hydroxide concentration is 0.1. That means barium concentration also 0.1. But the hydroxide ion concentration is 0.2, or else we can write 0.1 into 2 times, which is equal to 0.2. The OH minus concentration is given. OH minus concentration, find like this. And they have given us the Kw. You know the Kw is H3O plus concentration into OH minus concentration. The value is Kw is known to us, that is 1 into 10 to the power minus 14, which is a constant value. H3O plus concentration and OH minus concentration is 0.2. So now the only unknown thing is H3O plus concentration. So then I say that H3O plus concentration is equal 1 into 10 to the power minus 14 divided by 0.2. So therefore, H3O plus concentration is equal, if you simplify this by your calculator, it will give 5 into 10 to the power minus 14. Oh, now you know the H3O plus concentration, so why can't you find the pH? pH is equal minus log H3O plus concentration. pH is equal minus log H3O plus concentration is 5 into 10 to the power minus 14. So pH is equal to pH is equal to 0. pH is equal to 13.33. pH is equal to 13.33, and that is the answer. Right, that is the answer. Now, regarding this question, I have some background information to inform you. A set of background theory is there regarding this barium hydroxide. Is it a strong base or weak base? How do we came to know that? Right. We'll discuss that like this way. Now I'll erase this one. I guess you can pause the video if you want, so you can write whatever that you want. So see that I want to discuss the barium hydroxide. Now, you know, barium hydroxide is group 2 hydroxide. So what are these group 2 hydroxides? Are beryllium hydroxide, calcium hydroxide, strontium hydroxide, beryllium, calcium, strontium, sorry, beryllium, magnesium hydroxide, and the calcium hydroxide, strontium hydroxide, and the barium hydroxide. You know, down the group solubility increases. Solubility increase. You learned that earlier in the unit 2 classes. Down the group solubility increases. So barium hydroxide well soluble in water, so it can use totally OH minus signs. So that's why we work like a strong acid. We didn't try to find Kb, the dissociation constant in that. That is because it is a strong base. Right. Okay. I got my next one. That is mixture of 20 centimeter cube of 1 moles per cubic decimeter hydrochloric acid and 10 centimeter cube of 1 moles of sodium hydroxide. So I have two solutions. This is one and this is the other. The first container has what? Hydrochloric acid, HCl. The next one has sodium hydroxide. All right. So what is the concentration of hydrochloric acid? 1 moles per cubic decimeter, 0.1 m. M means moles per cubic decimeter. And sodium hydroxide concentration also 1.0 moles per cubic decimeter. From this one, what is the volume we take? 20. From this one, what is the volume we take? 20. And from this one, 10 centimeter cube. So I will find how many HCl moles and how many sodium. I mean that they are going to mix these two solutions together here. Sorry. Now then the total volume will be 30 centimeter cube. The total volume will be 30 centimeter cube. So now it is like this. I want to find how many moles of HCl there, how many moles of OH minus there. I mean, how many moles of H plus there? H plus moles, N is equal Cv. N is equal C is 1, volume is 20 divided by 1000. So the answer is 0.0. So it is answer is 0.02. Right. The next one is how much of OH minus ions there. So N is equal Cv, right? The N is equal concentration of the sodium hydroxide is 1 moles per cubic decimeter. So 1 volume is 10, so divide by 1000. So how much? That is 0.01 again, right? So this time it is 0.01. Now when we cancel these values are, you know, sodium hydroxide and HCl react 1:1 ratio, 1:1 ratio. So therefore, now HCl and sodium hydroxide reacts, makes sodium chloride plus water. So here 0.2 moles, here 0.1 moles. So how much of HCl remain? HCl remain out of 0.2, 0.1 is react. How much the HCl moles remaining? 0.1. So what is the one? Now I use C is equal N over V. Right? C is equal 0.1 is the moles of HCl remain. Total volume this time is 30. So I want to convert that into decimeter cube. So divide by 1000. Then the answer will be C is equal 0.333, like that. Then now how much of HCl remaining in this solution? Now I erase this one. You can pause the video to look whatever thing that you want. So here, now the H plus remains. Now the H plus remaining in this solution is 0.333. Now I can apply the pH equation for this one. pH is equal minus log H plus concentration. So I can say pH is equal minus log 0.333 something. So the pH is equal what? pH is equal 0.48. So C is the answer. So that is how we solve that problem. Right. Okay, I go to my next one now. Question number 4. Ammonia reacts with water in reversible reaction. Ammonia reacts with water in reversible reaction. Which are Bronsted-Lowry bases? Which are the Bronsted-Lowry bases? They ask which are the Bronsted-Lowry bases. Ammonia reacts with water. See that the way that ammonia reacts with water. This is ammonia, the NH3. It reacts with water, H2O. Ammonia reacts with water like this way. Now here, water is the Bronsted-Lowry acid there. So water donate H plus to this. I have explained that in the theory class. Water donate H plus. So water donate H plus to ammonia. So it makes what? NH4 plus, and then it releases what? OH minus. So now when the ammonia is acting as a base, this is a base, water is the acid. In the reverse reaction, ammonium is the acid because it donates the H plus and OH minus is the base. OH minus is the base. Ammonia reacts with water in a reversible reaction, which are Bronsted-Lowry bases. Now, in this one, what are the Bronsted-Lowry bases? Right? Which are Bronsted-Lowry bases? So, in this side, ammonia is the Bronsted-Lowry base, and the other side, OH minus is the Bronsted-Lowry base. So, the Bronsted-Lowry bases are ammonia and OH minus. So, these are the Bronsted-Lowry bases. Right now, I go to my question number 5. So I will give some time to read the question 5 and I will share it. You all to see. Okay, now anyhow, we see this question number 5. Suggest the most likely pH for each of the following solution. 5 moles per cubic decimeter hydrochloric acid. So they ask a question number 5. Suggest the most likely pH for each of the following solution. 5 moles per cubic decimeter hydrochloric acid. Right. So now, how can we build up the answer for this? We see that. So they are talking about the acid. The acid is HCl. The acid that they are talking is HCl. So it's a strong acid. So you need to know that it strongly dissociate H plus and Cl minus. Suggest the most likely pH for the following solution. 5 moles per cubic decimeter hydrochloric. HCl is 5 moles per cubic decimeter. HCl concentration is 5. So it's given H plus concentration also 5. And then now we apply the pH. pH is equal minus log 5. So pH is equal what? Right? So pH is equal 0.7. That is minus 0.7 is the answer. If you use the calculator, you will see that the answer is that. Right. And the next thing is again uh, little similar question to earlier one. This time it mentions 0.1. It should be, it's not well, I mean, it's not printed. 0.1 is the concentration. Yeah. 0.1 moles per cubic decimeter. 0.1 moles per cubic decimeter. Strontium hydroxide is the thing that we are talking about. We are discussing about 0.1 moles per cubic decimeter strontium hydroxide. Now, when we concern this is strontium hydroxide, also a strong base. It has a strong base, strontium hydroxide. So it uses Sr2 plus and OH minus, 2OH minus. The concentration of strontium hydroxide is 0.1. So OH minus concentration is 0.1 into 2. Right. So then the next thing is they have given us a Kw. They have given us a Kw. Kw is equal H3O plus concentration into OH minus concentration. Right. And the Kw, we can find the Kw is 1 into 10 to the power minus 14 is equal H3O plus concentration now. What is HCl plus concentration? We don't know that. That's what we want to find. And OH minus concentration is 0.2. Right. So then H3O plus concentration, we can find it. H3O plus concentration, we can find it by 1 into 10 to the power minus 14 divided by 0.2. So H3O plus concentration is how much? 5 into 10 to the power minus 14 if you simplify that. So now you know H plus concentration, so you can find the pH. The pH is equal minus log H plus, right? So pH is equal minus log H plus. So the pH is equal minus log 5 into 10 to the power minus 3, right? 5 into 10 to the power minus 3. So pH is equal, right? The pH is equal to that thing. So that will be 13.6, like ones will be 13.6, like, right? And then I go to the next one. The mixture of 20 of 0.1 nitric and 0.1 sodium hydroxide. It is exactly similar calculation like earlier. So I am not going to discuss that thing now because that is easy. Like earlier, the same type of calculation I did earlier. So I go to question number 6. Now we are to discuss question number 6. Question number 6 is in liquid ammonia, the following equilibrium is present: NH2 minus and NH4 plus and ammonia. See this one, NH2 minus plus NH4 plus, and it gives ammonia. Oh. So identify the Bronsted-Lowry bases. Now we see that This one donate H plus to here. So this is acid and this is what? This is base, right? Then this side ammonia. There are two ammonia. One of that ammonia acid, the other ammonia is a base. Understand that? So this there are two ammonia. If I write that ammonia plus again ammonia, one of that ammonia is acid, the other ammonia is a base. So which are acting as a bases? This side, who is acting as a base? NH2 minus. The other side, who is acting as a base? Ammonia. So these two are the couple which act as a bases. Right. Now I will finish that video with that 6 question. We will come up with another video to discuss the rest of the questions.